Alright, so today we're going to be doing the Algebra 1 Regents. It's from August of 2025. Okay, hopefully this will give you guys, some like help on this test, give you guys a little bit, solving it so you guys can have an understanding of what to do for these type of questions. Alright, so for part 1 we have a bunch of multiple choice questions. These shouldn't be too bad. Alright, so first question number 1, which expression is equivalent to 100x squared minus 16? So this one we have a difference of squares. So we have a squared minus b squared is equal to a plus b times a minus b. So that's just kind of like one of the factoring patterns that you have to be able to recognize. So we'll see that kind of like if you take the square root, if we take the square root of 100x squared, that's 10x. And then 16, the square root, that's 4. So we have 10x plus 4 and then 10x minus 4. So then that's how you factor it. The answer to number 1 is 3. Okay. Josie has $2.30 in dimes and quarters. She has 2 more dimes and quarters. Which equation below can be used to determine x, the number of quarters she has? So she has, so x is the number of quarters. So x is equal to quarters. So we know that she has 2 more dimes than quarters. So that means x, which represents the quarters. So let's actually put dime. So 2 more dimes than quarters. So I'm going to put that as d. So 2 plus 2 more dimes. Hold up. 2 more dimes than quarters. Okay, this is the part where I kind of like to take my time with deciphering the message. So 2 more dimes than quarters. So there are more dimes than quarters. So d is equal to x plus 2. So now we have $2.30 in dimes and quarters. So for dime, that is a dime is 10 cents. So it's 0.1 times x plus 2 plus a quarter is 0.25x, and that's equal to $2.30. And number 2, the answer is 3. That one matches it. Yes. Okay. If g of x is equal to negative 2x squared plus 16, then g of negative 3 equals. So this one is really simple. You're just plugging in negative 3 for x. So negative 2 times negative 3 squared plus 16. So that's equal to negative 3 times 9 plus 16. So when you square, the negative is also being squared. So that becomes positive. Negative 18 plus 16. So this becomes negative 2. The answer is choice 2. Okay, what are the zeros of x squared minus 8x minus 20? So what you can do, of course, is just graph on your calculator and see where the zeros are. So you would put graph, and then you would get a graph, I don't know, something along the lines of that. And then you would use one of the functions in your calculator, and it should be like second calc, and then you go to like trace, and then you go to zeros, and you kind of like pinpoint it. Or if you can, just look on a graph and see where the zeros are. But what we're going to do is actually we're going to factor it. So x minus 20. So I want to find 2 numbers that multiply to negative 20 and add up to negative 8. So I'm thinking of 2 and 10. One of them has to be negative because it multiplies a negative number. And since they add up to negative 8, 10 has to be negative. So that these two, when they add up, it becomes negative 8. So this can be factored into x plus 2 and x minus 10. And then you can check that, when you expand it. So we're solving for the zeros. So what we're going to do is just set the kind of like the expression equal to 0, and we're going to see when, that expression is equal to 0. So now that it's in factor, either one of the factors has to be 0 in order for kind of like the equation to be true. So we have x plus 2 is equal to 0. So if I just set that equal to 0, I get x is equal to negative 2. And then x minus 10 is equal to 0. Then I get x is equal to 10. So my 2 roots are x is equal to negative 2 and x is equal to positive 10. So number 4 is choice 2. Okay. Which point lies on the graph y equals 3x squared minus 1/4 x plus 3? So for this one, what I would do actually is I'm going to use a calculator. I had a calculator app here. Is it here? Let's see, where's my calculator? Okay, here we're gonna use this one. I'm actually going to do this. Okay, it's really annoying. Not good notes, notability. Sorry. Okay, this is really bugging me. Okay. All right. So I have a calculator. This is gonna look close enough to what you're gonna see with the TI-84, which is probably what you're gonna be using. I'm gonna go to y equals, and I'm gonna type in the equation. So we have 3x squared minus 1/4 x plus 3. And I'm gonna graph it. Yeah, sure, but I'm actually gonna go to the table, and all of these kind of like I'm gonna really focus on the x coordinates. So let's look over here. So x is equal to -2. We get that 15.5. Okay, well, that's the answer. Don't even gotta look at the other options. Oh, okay. It's crashed out on me. Yeah, that's the other option. Okay, given f of x is equal to x squared and g of x is equal to ax minus 15, graph on the same x of axis, which values of x make f of x equal g of x? So we just gotta set the two equal to 0. Set the two equal to each other. So this is equal to this. So we have x squared is equal to 8x minus 15. So then now I'm going to solve this like a quadratic equation. So when you're solving quadratic equations, you want to make them equal to 0. So I'm going to move everything on the right-hand sides over. And I get this, and this is a factoring problem. So I'm going to find two numbers and multiply to 15 and add up to -8. And I'm thinking of 3 and 5, since they add up to -8, both of them are negative. So we just have x minus 3, and then x minus 5 is equal to 0. So x is equal to 3 and x is equal to 5 when I set each of the terms equal to 0. So the answer is choice 3. Okay, which trinomial is written in standard form and has a constant term of 5? So constant term of 5, that means the last, like, kind of like the number by itself without any x is equal to 5. So we can eliminate 1 and eliminate 3 because not 10, not 1. These are good. 5 is good. And now it's in standard form. So then that means when we have a polynomial, the powers are decreasing. So if we look at choice 2, this goes from x squared to x to the power of 4. That's not decreasing. So this is not in standard form. But this over here, it goes from 5 to 2. The power is indeed decreasing. So the answer is choice 4. All right. When solving x squared plus 6x equals -8 for x, the student wrote x squared plus 6x plus 8 equals 0 as their first step. So what they did was add 8 on both sides, which property justifies this step. So associative property is just you're able to kind of like, so like associative property. So this is equal to this. Whatever you associate together doesn't really matter. Commutative property is that the order doesn't matter. So that zero property of addition is that when you add something, it remains 0. So we have let's say like 1 plus 1 is equal to -1 plus 1 is equal to 0. And then the addition property of equation is basically whatever you do to like one side, you can do it to the other side. Let me rephrase that. Shoot. Oops. Okay, wait, scratch that. So wait, hold up. Let me go back to the zero property of addition. Sorry, I was thinking about something else. So zero property of addition is basically whatever when you add 0, right? It doesn't change anything. So if you have a plus 0, that's still equal to a. And yeah, and then the addition property of equality is that kind of like whatever you add to one side, you do it to the other side. You also add it to the other side to remain equal. So you have like a. So let's say we know that a is equal to a, right? And then if I add b on this side, the equality would not. If we add b on the left hand side, the equality wouldn't hold. But then if we add b on both sides, then the equality would still hold. Okay. The table below shows the input and output values for functions, which one represents a linear function. So if I want to think about a linear function, we have a constant like increase between this. So this one is plus 5. This one is minus 3. So this is, of course, not it. This is minus 1, minus 1, minus 1. And then we have plus 1, plus 1. This is not constant, not it. This one is minus 1, minus 2, minus 4, minus 8, and minus 16. Also not it, not constant. Plus 4, plus 4, plus 4, plus 4, and plus 4 constant. So when we have a constant increase, a constant rate of change, that signifies a linear function. So the answer for number 9 is j of x, choice 4. Okay, what is the solution set to the equation 3x squared is equal to 24x? So this is an kind of like set notation. We have a set of values. Don't let that throw you off. Those are just the values of x that makes the equation true. So let's solve it. So again, we have a quadratic equation because we have 3x squared. So what I'm going to do is, with all quadratic equations, I want to set the equation equal to 0. So 3x squared minus 24x is equal to 0. And this is a pretty easy factoring problem. It's not a trinomial, so I can just use the greatest common factor method. So the GCF, I'm going to look at the numbers. 3 and 24, the GCF is 3. X squared and x, the GCF is x. So then now I'm going to, so if I pull out a 3x, I'm left with x for the first term. And then if I pull out a 3x, I'm left with minus 8 for the second term. So then now when I set each of them equal to 0, so this factor equal to 0 and this factor equal to 0, I get x is equal to 0 and x is equal to 8. So my solution set is choice 2. So this is just a set, kind of like representing like set with elements. Don't let that throw you off. Okay, table shows the radioactivity level of the substance, blah, blah, blah. We don't really gotta worry much about that. Average rate of change in the radioactivity level over the interval 1 is less than or equal to t, which is also less than or equal to 3. So the average rate of change formula, so from like over the interval from like A to B. So from like A to B, I'm just gonna put it in interval notation because I don't know what variable it might be. F of b minus f of a over b minus a. So that is the rate of change formula. Think of this as your function, and then this kind of like your input. So I want it to be over that interval, so I'm going to have f of 3 minus f of 1 over 3 minus 1. So f of 3 is 2.5 minus f of 1, which is 10, over 3 minus 1, which is equal to 2. For these like arithmetic, I would recommend using a calculator. Like for example, you can use a calculator for the full test, so never have to worry about that. I'm not really good with arithmetic, so I'm gonna use a calculator. It's negative 3.75. So the answer is choice 2. All right, make sure the order you want to kind of like do like new minus old over old. Well, new minus old, because kind of like your percent change, you want to take like how much it like increase or decrease by, and then you divide it by like kind of like the time interval. Okay. Fred recorded the number of minutes he read each day from Monday through Friday. His results are shown in the table. What is the correlation coefficient to the nearest thousands and the strength of the linear model of these data? Okay, so this one we're gonna be using the calculator, and I don't really like using this iPad dupe of the TI-84 because the functions are a little bit kind of like it looks a little bit wonky. I wish I could there's the online TI-84 that I can do on my laptop, but I just can't show it on here, which is a tad bit annoying. Okay, so we're gonna go to stat, and then we're gonna do edit. So then now we're given a list. I'm gonna actually clear the list. So I would just like recommend that like maybe you can like reset your calculator beforehand. So I'm pretty sure they're supposed to like ask you to like reset your calculator before the test. That gives you a good start. Your list should be cleared. I think that makes it a little bit easier. So for list 1, L1, I'm gonna put in the day, so it's just gonna be 1, 2, 3, 4, 5, and then I'm gonna move over to list 2. I'm gonna put 12, 16, 19, 27, and 29. Okay, now I'm gonna go back to stat, and I'm gonna press calc, and then I'm gonna put linear. I'm gonna put linear regression. So linreg 8, and then my x is gonna be my list, and then I'm gonna have does it give me, okay, the R, I don't know, let me just do on the calculator real quick, on the actual physical calculator that I have, because I don't know if the R, the coefficients shows up, if you, because it might show up and it might not show up. Let me just double check something. Okay, stat, I'm gonna go calc, and then linear regression. Okay, so if your R doesn't show up, what you're gonna do is you wanna go to mode, and then do they have this here? Okay, the stat diagnostics, you wanna put that as on, and then you get the R. So then my R, so the okay, so the correlation coefficient, that's just R. That's gonna be 0 point, hold up, did I type in one of these wrong? Go to stat calc. Let me see the list again. Oh shoot, I forgot to put the last one. Okay, that's why. Okay, I'm gonna go back to stat calc, and then I'm gonna go to linear regression, and then just gonna repeat the steps. Okay, R is my correlation coefficient, and it is 0.9838. So then it's either choice 1 or choice 3, and then now whether it's strong or weak, it depends on how close it is to 1. So 1 means that for sure there's a linear relationship, and then when it's like pretty close to 1, then yeah, it's a good enough linear, there's like the linear model is like good enough, but then the like kind of like the lower it gets, then it's not, and if it's positive, then it's a like a positive linear relationship. So this one is positive, so it's gonna look like something like this. Negative, you're gonna get something looking like this, and the answer is choice 1, because 0.9 is pretty close to 1. So yeah. Okay, given f of x is equal to x squared, which function shifts f of x to the left 3 units? So we're doing a horizontal shift, so whatever we're gonna do it to like x itself. So it's not gonna be, we're not gonna have 1 or 2. That's these two, they're vertical. So choice 1, it actually moves x squared up 3 units, and then choice 2 moves it down 3 units. So then now when we have the horizontal, like the phase shifts, this is going to be a little bit more counterintuitive. So we're kind of like going in reverse. So this direction, we're actually going to be subtracting. So if we're going to the right, it's going to be subtracting. If we're going to the left, it's going to be adding. So we're going to go to the left 3 units. So it's going to be x plus 3 squared. So 13 is choice 4. Okay. Class of 20 students was surveyed to determine the number of pets each student owned. The data represented in the dot plot below, which statement about the data is true? Okay, this one's a little bit annoying. This asks about mean, mode, and median. So for this one, the mode is pretty simple. The mode is 2, so that's the most, and we have 20 students. So I'm just going to count to 10 to find the median. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the median is also going to be 2. So kind of like my middle value is somewhere between those two, and I would take the average, and it's the same thing, so it would be just 2. Okay, now the hard part is the mean. So what you can do is just so 0, so this would be 0, this would be 4, and then it's 1, 2, 3, 4, 5, 6. 6 times 2 is 6 times 2 is 12, and then we have 4 times 3, which is also 12. Oh, this is 12, and then this is 10, and I'm going to take the average. So 4 plus 12 plus 12 plus 12 plus 10. I'm going to divide that by 20, and the mean is 2.5. So it's different. So the median and the mode are the same. So number 14, the answer choice 2. Okay. the range of f of x blah 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 is equal to this. All right, so for the range, you kind of like, so we had the function y is equal to absolute value of x. We get something along the lines of this. All right, the range is going to be from 0 to infinity, and then now the horizontal shifts, that does not affect your range. Your range is your set of y values. So then now what does affect the range is the vertical shifts. So we have -5 here. That means I am transforming down by 5 units. So then now this, if I move it down by 5 units, it would become from -5 to infinity. So infinity, that's always going to be the same. It's going to increase without bound. So well, there's range. So I'm going to eliminate 3 and 4 because that's give you like the domain. And now I'm moving it down 5 units. So the answer is choice 1. Okay, which equation is always correct? So when we have multiplying, so this has you like the rules of exponents. So this is wrong. This, I don't know about this, but this would be a to 3 plus x. I will add the powers. This is wrong. This would be a to the 4 times x. So when you raise like a power to another power, you would just multiply the powers together. This one is indeed true. Yeah, you can kind of like break it out. This, I don't know about this. It's kind of like we can't kind of like combine the exponents unless the unless the base is the same. So this is incorrect. So the answer is choice 3. The formula for the areas of a trapezoid is a is equal to 1/2 height times base 1 plus base 2. The height of the trapezoid may be expressed as. So we have a little equation and we're just solving for a variable h. So this one is actually not too bad to solve for. So we're trying to solve for h right now, and there's a bunch of things attached to it. So first, let's get rid of the 1/2. So 1/2, to get rid of it, I'm just going to multiply both sides by 2. So this becomes 2a is equal to h times base 1 plus base 2. Now I want to get h by itself, and the only thing that's attached to it is this over here. So I'm going to divide both sides by b1 plus b2. So then 2a over b1 plus b2 is equal to the height. So 17, the answer is choice 1. All right. The functions given below, which functions have the same y-intercept. So the y-intercept, that's when x is equal to 0. So the y-intercept for this one is -3. I'm just going to plug in 0. I don't want to bust out the calculator. So this is absolute value of 2, negative absolute value of 2 plus 7. So that's just equal to 5. G of 0 is equal to, so this is -3 squared minus 9. So this is minus 4. This is 9 minus 4, which is equal to 5. So that means f and g have the same the y-intercept. All right, this has a little bit of lingual. You have to know what y-intercept is. That's just when x is equal to 0. All right. The sum of x plus 7 quantity squared and x minus 3 quantity squared is. So what I'm going to do actually is I'm going to expand it. So this is x plus 7 squared, and that's equal to x squared plus 14x plus 49. So this is just expanding a binomial square, a squared binomial. All right, you should be familiar with this. So this is x squared minus 6x plus 9. And then when I combine these two together, this becomes 2x squared plus 8x plus 58. So this is choice 3. Okay, the product of this and that is, so we have 2 root 10 times 3 root 2. So the operation between 2 and square root of 10 is just multiplication. So technically what we can do is use the commutative property of multiplication and rearrange these things. So this I can do 2 times 3 and then root 10 times root 2. So 2 times 3, that's just equal to 6. That's easy. And then now the square roots, I can multiply them together. I can just multiply whatever's underneath the square root, the radicand together. So that is just 10 times 2, which is 20. So this is 6 root 20. And then I'm going to simplify this. Root 20 is equal to root 4 times root 5, which is equal to 2 root 5. So then this is equal to 6 times 2 root 5, which is equal to 12 root 5. So the answer is 5. Alternatively, what you could have done is just multiply it and kind of like guess it out in your calculator and see which one matches. All right. When 6x cubed minus 2x plus a is subtracted from 5x cubed plus 3x minus 4, the result is, so we're gonna do this minus this. And you can kind of see that, okay, so 5x cubed minus 6x cubed, that's equal to negative x cubed. 3x cubed minus negative 2x, 3x minus negative 2x is 5x. And then negative 4 minus 8 is negative 12. So the answer is 3. All right, be careful of the order. It's subtracted from, so that's why I have 5x cubed, blah, 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 minus 6x cubed, blah, blah, blah. Okay, relations are shown. Which one represents a function? So a function must passes the vertical line test. So, okay, well, actually let's look at number 1. So function, basically for each input, you can't have more than one output. So 0, okay, no repeat, no repeat, no repeat, no repeat. Okay, good. So this one is a function. All right. 3 maps it. Okay. No repeat. No repeat. No repeat. No repeat. Good. So this is also a function. And now when we have a graph, it must pass the vertical line test. So no matter where we draw a vertical line, there can't be like a vertical line where there are more than one point of intersection. And kind of like the only points of concern are kind of like with these like step functions is what happens here. These two are, they don't, there's only one value on that vertical line because this is an open circle, so that doesn't count. It's only this closed circle that counts, and you can see that this is the same over here. So all of these are indeed functions. Okay. Method of substitution was used to solve the system of equation below. Which equation is the first step when using this method? So when I'm using substitution, I want to isolate a variable. So I'm probably going to be looking at the second equation. So substitution, I want to get a variable by itself. So it's either x or y. So I'm going to eliminate 3 and 4. So then now if we look at here, so we have x minus y is equal to negative 1. If I add y on both sides, this becomes y minus 1. So the answer is choice 1. And y is choice 2 wrong. So x minus y is equal to negative 1. So I'm gonna okay, let's just use this equation again. So I get that x is equal to y minus 1. If I add y on both sides, add 1 on both sides, this becomes x plus 1 is equal to y. And the sign is wrong here. This should be a plus. Okay. In 2009, Usain Bolt, a sprinter from Jamaica, set a world record in the 100-meter dash with a time of 9.58 seconds. His approximation speed in kilometers per hour can be found using which conversion? So this we have kind of like unit analysis. So we want to, so I want to find kilometers per hour. So kind of like I'm gonna just keep with the kilometers per hour. I'm gonna have distance over time with what I'm starting with. So the distance is 100 meters over 9.58 seconds. I'm going to eliminate that. So first, if I want to convert, okay, let's look at choice 2. So this first conversion factor, I'm converting from minutes. I'm converting from seconds to minutes. So this is good. This and this cancels out. So then this becomes meters per minute. And that moves us forward. And then now we're going to convert it from, it seems like the next conversion factor converts from meters to kilometers. However, the meter does not cancel out. So I have like meters squared over kilometer, which does not make any sense. Choice 2 is wrong. For this one, so for choice 3, it seems like we're converting from meters to kilometers first, and the meter cancel out. So now we have kilometers per second, and then it's good. But then now it seems like they're trying to convert from minutes to seconds, and they're both in the denominator, so they don't cancel out. I'm not converting it to minutes, so this is wrong. And it seems like choice 4 has to be the correct answer now. So the first conversion factor, so it converts from seconds to minutes. So the second cancels out, works perfectly fine. And then it converts from meters to kilometers. Meters cancel out, perfectly fine. And then now the last thing, the last thing is converting from minutes to hours. And the minutes cancel out. I'm left with kilometers per hour, and the units match up. Okay, all right. That's it for part 1. Maybe come back with part 2.